Hello students, welcome to the channel. In today's video, we'll discuss the basics of quadratic transformations. Quadratic functions when graphed on the coordinate plane are parabolas. So this is effectively a video on transformations of parabolas. So let's begin. So the first thing we need to be comfortable with is the representation of a parabola and the three forms of the parabola that you should know for the SAT or the ACT. So let's say I have the parabola x squared plus 3x plus 2, right? Now, there are three ways that I can write it. One is just the way it's written, which is known as the y-intercept form, because when you put x as 0, y is 2. That means that the y-intercept of this parabola is 2. And since you can see 2 as a constant here, this becomes the y-intercept form. There are these questions that you must have come across on SAT math where they say that represent this parabola in a form where you see the y-intercept or the x-intercepts or the vertex as constant or coefficients. So this slide explains that, right? So this is the y-intercept form. The x-intercept form is achieved or is obtained when you factorize this. That is when you split the middle term and write the expression as two factors. So x squared plus 3x plus 2, when you split the middle term, you can write it as x squared plus 2x plus x plus 2, which is x plus 2 times x plus 1. And that is the x-intercept form, because this gives you the x-intercepts minus 2 and minus 1. And you can see that this parabola has x-intercepts at negative 2 and negative 1. So since you can see those numbers as constants, this is known as the x-intercept form. And the third form is the vertex form. And for the purposes of transformations, this is the form we are most interested in. So let's understand what the vertex form is. So the vertex form of a parabola, the general form is a times x minus h whole squared plus k, where h comma k is the vertex, right? So if I were given the y-intercept form, for example, x squared plus 3x plus 2, then how do I convert it into this form? I've explained this in a video called Completing the Squares, which I will link to in the description box. You basically have to complete the squares in this. So you write this as x squared plus 2x times 3 by 2. This expression, 3x is written as 2x times 3 by 2. And then you add the square of whatever is here. Plus 2 was already there. And since you have added the square of 3 by 2, you have to subtract the square of 3 by 2. Why do you do this? You do this because a plus b, the whole squared, is a squared plus 2ab plus b squared. So you're trying to convert these first two terms into this kind of an expression. You can see x squared plus 2 into x into 3 by 2 plus 3 by 2 the whole squared. So this would in turn give me, right, 1 second. Yeah, this would in turn give me y is equal to x plus 3 by 2 the whole squared plus 2 minus 9 by 4, which is y is x plus 3 by 2 the whole squared minus 1 by 4, right? And that, as you can see, is the vertex form, x plus 1.5 the whole square minus 0.25. And if you compare this to the standard equation, then the h value will be negative 1.5 and the k value will be negative 0.25. So this point, the lowest point of the parabola, would be negative 1.5 and negative 0.25, right? So this is the first thing to know. Before we come to transformations, we have to be absolutely comfortable with the vertex form. Now, how do we transform parabola? Let's understand that. Let's say I have the most basic parabola, right? The most basic parabola being y is equal to x squared, which is a parabola that has a vertex at the origin, right? This is the origin. So this is the parabola y equal to x squared, right? Now, if I move it 2 units to the right, which means that if I move it 2 units along the x-axis, I get a new parabola with the vertex at 2, 0. And the equation of this would be y is equal to x minus 2 the whole square. So just as we had seen in linear transformations, a move of 2 units to the right implies a change in the x of -2, right? So that happens when we move it 2 units to the right. Let's move it 2 units to the left. If I move it 2 units to the left, then my vertex shifts to -2, 0. And this equation would be y is x plus 2 the whole squared, right? So 2 units to the left indicates a shift from x to x plus 2 in the equation. Right, so this is along the x-axis. What happens if we move the parabola up and down? So let's try and look at that. So let me clear this. Okay, this. Okay, I think I've cleared everything. This is well, yeah. Okay, now if I'm moving the parabola 2 units up, then my new parabola is here. And the vertex is now 0, 2. And this is y is equal to x squared plus 2, right? So here the plus 2 is outside the x, right? We are not changing the x value. We are writing plus 2 outside it. If I move it 2 units down, so let's say my parabola comes here and my vertex becomes 0, -2, then the equation is y is x squared minus 2. And if you think about it, effectively, you're applying the same rule to the shift along the y-axis as you applied to a shift along the x-axis. When you were shifting right 2 units, you replaced x with x minus 2. Similarly, when you're shifting up 2 units, you are replacing y with y minus 2. Effectively, you're doing the same thing. So this equation was in fact y minus 2 is x squared. And when you take -2 to the right-hand side, you get the equation that we have. Similarly, when you shift left 2 units, you were replacing x with x plus 2. And when you shift down 2 units, you're replacing y with y plus 2. So this equation is basically y plus 2 is x squared, right? So if you want to remember it as a rule of transformation, then you should remember that shifting right implies a change in x by you replace x with x minus whatever units you've shifted right. Shifting left means you replace x with x plus whatever you've shifted left. Shifting up means you replace y with y minus whatever amount of units you're shifting up. And shifting down means you replace y with y plus however many units you're shifting down, right? Okay, then we have this last expression. So let's understand that. I'm just going to clear everything. Expression here, y is equal to -x squared. So I also want to discuss that, right? We have drawn a parabola y is equal to x squared. And we know that y is equal to ax squared plus bx plus c, where a is the leading coefficient. Now, the purpose of the leading coefficient is to determine the shape of the parabola. Let's say I replace y is equal to x squared with y is equal to 2x squared. So here a is 1, and I make a parabola y is equal to 2x squared, where a is 2. This parabola would be slimmer than y is equal to x squared. Similarly, let me make a parabola y is equal to half x squared, where a is half. This parabola would be fatter than the parabola for y equal to x squared. So the value of a determines the shape of the parabola, right? What happens when I do y is equal to negative x squared? Then my parabola is a reflection of y is equal to x squared on the x-axis. And this is in fact a useful rule that when the leading coefficient is positive, the parabola opens upward. And when the leading coefficient is negative, the parabola opens downward. So this is the basics of parabola transformations. Let's now do some sample questions. Question 1, the parabola y is equal to x minus 5 whole squared plus 2 is shifted so that its vertex, the vertex of the new parabola is 5, negative 7. What change to the initial parabola causes this? So if I were to draw the initial parabola, from this I know that its vertex would be 5, 2, because this is the vertex form. So this is the vertex of my original parabola, 5, 2. And now my new parabola is here with a vertex of 5, negative 7. So the x values are the same, but the y value has gone from 2 to negative 7, which means there were 2 units here and there were 7 units here. So I have shifted the original parabola 9 units down to get the new parabola. And so I'm moving it down 9 units, option A. Okay, let's look at the second question. The parabola y is equal to x squared minus 4x plus 3 is shifted 5 units to the right. In this new position, the equation of the parabola is y is equal to x squared minus 14x plus d. Determine the value of d. So when I have y is equal to x squared minus 4x plus 3, and I shifted 5 units to the right, then that is effectively saying that x should be replaced by x minus 5, right? That's what a shift to the right means. So my new parabola should be x minus 5 the whole squared minus 4 times x minus 5 plus 3. So wherever I have x in the equation, I replace it with x minus 5. So that becomes x squared minus 10x plus 25, because x minus 5 the whole squared would be x squared minus 10x plus 25 minus 4x plus 20 plus 3. So that's x squared minus 10x minus 4x is minus 14x plus 25 plus 20 plus 3, which is plus 48. So the equation of the new parabola is x squared minus 14x plus 48. So D is 48, right? Okay, let's do one more. The quadratic function fx is defined by fx is equal to 2 times x plus 2 whole squared minus 1. So I know that the vertex is negative 2, negative 1, right? Because this is the vertex form. So let's say negative 2 and negative 1. This is my vertex. And let's say my parabola will look like this. In the xy plane, which of the following could be the graph of y is equal to fx shifted 3 units to the right? 3 units to the right would mean that my parabola would come here from -2 to +1, right? The y value won't change, but the x value would go from -2 to +3, which is +1. And so my new parabola should look like this. It should have its vertex in the 4th quadrant. So if it should have its vertex in the 4th quadrant, obviously C and D are incorrect. And between A and B, I know that my leading coefficient is positive. So it should be an upward opening parabola, right? So it can't be A. The right answer is option B. So that was parabola transformations. Hope this exercise was useful. If it was, hit like and subscribe to the channel. Let me know what other videos you'd like me to upload. I've been making videos on math fundamentals, which are part of the Basics Explained playlist. I'll be adding more in the coming days. I'll see you guys in a new video soon. Take care. Bye-bye.